and along with Rashi Jain, we are here to present a topic on architecture of Linux and basic directory structure of Linux. So let's understand with what is Linux. Linux is an open source Unix-like operating system kernel which was created by Linus Torvalds in 1991. It forms the base of many operating systems like Ubuntu, Fedora, Debian, and CentOS. Linux is widely used in servers, mobile devices, and even supercomputers due to its stability, security, and flexibility. It follows a layered architecture which separates hardware from user interactions. So let's dive into the topic, that is Linux architecture. As you can see in this diagram, this is how the layers are. So let's understand the first layer, that is the hardware. But before that, let us first understand the basic overview of Linux architecture. Linux architecture is divided into multiple layers, as I just showed you. Each layer has a specific role and interacts with the user to ensure smooth system functioning. The layers include hardware, the first layer, then the kernel, system libraries, shell, system utilities, and then the user applications. So the first layer is hardware. It is the lowest layer of Linux architecture. It includes all the physical components such as CPU, RAM, storage devices, input output devices, and network interfaces. Linux communicates with this hardware through device drivers which are managed by the kernel. The next layer is the kernel. We can say that it is the heart of the Linux OS. It acts as the bridge between the hardware and the software. Its main responsibility is to include process. Its main responsibility includes process management, memory management, file system management, device driver management, system call interface, and network management. It also provides system call interface for communication. There are various kernel level commands available. In this layer, user interacts with the system using various commands, as you can see in this PPT, that directly or indirectly interacts with the kernel. These commands help in managing processes, files, and system resources. Some of these commands are uname-r, lsmod, modprop module, and etc. The next layer is system libraries. It is the third layer. Uh, it provides predefined functions that help applications to interact with the kernel. Applications do not communicate directly with the kernel. Instead, they use these libraries. An important example is GNU library, which is also known as glibc, which provides wrappers for system calls like open, read, write, for. There are other important libraries, for example, lib, libpthread, which is for POSIX threading, and others for math library, SSL library, and others as well. The next layer is the shell. The shell acts as an interface between the user and the kernel. It takes user commands, interprets them, and sends them to the kernel. There are two types of shells. The first is command line, and the second is user interface. There are various examples of shell which are available. For example, bash, sh, zsh, ksh, and csh. We popularly use born again shell, that is bash shell, and it is the default model in many distros. There are various shell commands available, as you can see in the PPT slide. For example, echo shell, bash shell, history, and various as well. Then the next layer is the system libraries. It is the fifth layer, which includes user level programs that perform specific tasks. These utilities are standard tools provided by the Linux system. They help in file management, system monitoring, and other operations. Then the next layer is the user or application layer. It is the topmost layer where the end user like us interact with the system. It includes system applications like file managers, user applications like browsers, and development tools like compilers. User interacts either through command line or graphical interface. We can understand this all with one example. Like for example, we are using a mobile phone और उस मोबाइल फ़ोन पे हमारे पास एक ऐप है फॉर एग्जांपल व्हाट्सएप जिसे हमें यूज़ करना है. So this is how we use it and this is how the app interacts with the uh, whole system. So this is how it follows. The user taps on the app icon, which is the shell or the UI we can say. Then the system libraries helps apps to communicate with the system, and then it goes to the kernel, which manages the memory, app, and the hardware. And then comes the hardware, which manages the CPU, battery, and screen. Now, I would like to hand over the mic to the Rashi to continue with the next topic, that is basic